Hello, Andy. Sorry. So, where were we? We were discussing on the second normal form, right?
Yeah.
Okay, I'm sharing my screen. I thought of removing this 40 minutes, but again, I feel that, at least we'll go and have some water and all. It is good to have a break. Otherwise, I'll have to. Okay.
Okay.
And even uploading also, I thought, at least, and I have a doctor, okay, 5 to 10 minutes break and తీసుకొని for every half an hour అని చెప్పేసి చెప్పారు. I have this.
అవునవునండి. ఇంపార్టెంట్ అని చెప్తారు చాలా.
We tend to ignore. We usually it is not like intentional.
వర్క్ లో ఉంటే అసలు పట్టించుకోము అదే.
అదే నాట్ ఇంటెన్షనల్లీ బట్ అది అలా అవుతుంది. సో అందుకని ఇట్స్ కైండ్ ఆఫ్ రిమైండర్ అన్నట్టు అనుకున్నాను నేను కూడా. ఓకే, సో నౌ this transitive dependency, any subset of y of x, meaning like, the subset of course is not directly dependent on this value, z something, y to a also holds good. Meaning there is no transitive dependency. Something like a to b holds good and b to c holds good, then a to c also holds good, right? Similar to that. So second normal form, what it will do, it will only establish the relationship between two or more entities using a common key known as a candidate key or foreign key. Primary and foreign key relationship will be there. Okay. So 2NF is nothing but, you don't have to give this theoretical definition to anyone because people will get confused. I will remove that from mathematical definition also that I just gave. So what is 2NF?
Okay.
2NF is a second normal form. We are actually maintaining the data into relationships, right? So two or more entities in the sense tables will be combined through a common key known as candidate key. Remember, candidate key is a kind of theory only, but when it comes actually the database and all, candidate key is a kind of superset of foreign keys. And it is not only one key, uniqueness that has been identified. But a candidate key is nothing but an integrity that we are maintaining. If you take an example of CID. Okay, course ID, which is a kind of preferential integrity that I'm maintaining. So for this table, course table, it is a foreign key to the primary key of this, or foreign key to the primary key. Referential integrity, when we talk about referential integrity more, we'll discuss on that. Okay.
Okay, so two or more entities will be combined through a common key known as candidate key. So here candidate key is CID, right?
Right.
Okay.
What we mean by candidate key is the key that establish the or reference to the primary key or anything. Okay, candidate key. What is a candidate key? Key column that refers to the master table.
Key column that refers to the master table.
The common key between the
Okay, common key that establishes relationship between two tables.
right.
That could be two or more, right? Or it's
right,
only
two or more, any number of tables, right? But if it is more, right, what it will happen in 2NF, only like, this, okay, there is one more table. If I split this into zip and city into one more table, I'm maintaining it. Okay.
Okay.
Because these are all the less number of data, I do not have to repeat it. If I'm just going to maintain it into one more table, right, zip and city, I don't have to mention. Then you have only zip. You can just mention, or zip you mention address or head. Okay.
So because it is numbers only, it can
Numbers
stay.
only it will not store. Or you can just maintain something like one more key also over here, like Z_ key that will go to as a data warehouse also. We'll see that. So that Z
No.
key will be there. You can just mention only even whichever it is, like a chip value, you can just mention, and the city. If you just type in the chip value, they are connected through chip value over here.
Okay.
And the address details, anything, everything. This is city, address 1, address 2, all these things will come. Okay.
Okay. So
Zip.
the common between these three is zip.
Zip, yeah. Address 1, address 2, lane, county, whatever it is, everything is coming. State, country.
Okay.
Okay. Whichever is the unique one. So here, this table also is referring to this particular, table. Okay, let me establish the relationship. Get to know. Excel will do a lot, but unfortunately, okay. This zip, this table is dependent on this also. Let me merge and see. Okay, there is a relationship between student to course. Okay, and again, student to zip also there is a relationship. Again, course to zip also there is a relationship. Right.
Student to zip and course. Okay, yeah.
Right. 1 second. I wanted to draw the line, so I'm just checking. I have downloaded this something like, because my MS Office, whomever I'm asking, and they're not genuinely, okay, drawing objects properties. Yeah. They are not installing genuine MS Office. Double తీసుకుంటున్నారు కానీ. So I have downloaded
Okay.
this Open Office. Some
Okay.
little, right. Not letting వెళ్ళాడు కనిపించడం, ఫోన్ ఎత్తడం, నేను ఇన్స్టాల్ చేయించడం, మళ్ళీ పోవడం, రాసేసి దానికి.
మళ్ళీ ఫోన్ ఎత్తారా వాళ్ళు ఇంకా?
మళ్ళీ ఫోన్ ఎత్తరండి, అలా తయారైపోయారు అసలు. వేసుకుంటున్నారు, చాలా అయిపోతుంది. Insert rows, picture, insert picture. It's from file, open file. They're all some properties, some lines and all will be displayed in MS Office. So I was just trying to providers value.
అది మీరే ఇన్‌స్టాల్ చేసుకోవచ్చు కదండీ జెన్యూన్ ఎంఎస్ ఆఫీస్.
అంటే సైట్‌లోకి వెళ్లి చేసుకోవచ్చు. ఐ ట్రైడ్ దట్. సమ్‌హౌ ఇట్ డిడ్ నాట్ హ్యాపెన్ టు మీ అండి. సమ్‌వేర్ ఇట్ జస్ట్ స్టాప్డ్. ఐ గేవ్ మై క్రెడిట్ కార్డ్ డీటెయిల్స్ అండ్ ఆల్ ద లైసెన్సింగ్. ఇక్కడ ఎందుకో నాకు అది
ఓహ్!
అవ్వలేదన్నమాట. మేబీ ద స్పీడ్ అండ్ ఆల్ ఈస్ నాట్ సఫిషియంట్. దెన్ దే సెడ్ ఓకే, నా దగ్గర సీడీ ఉంది, అని చేసిస్తాము అన్నారు. ఎందుకో ఒకసారి రిపేర్‌కి ఇచ్చినప్పుడు ల్యాప్‌టాప్.
ఓహ్!
సరే చేసేసి ఇచ్చేయని చెప్తే వాళ్ళే చేశాక పీపుల్ మై
ఇది ఓల్డ్ వర్షన్ కదా ఇది?
ఏంటండి?
ఇది ఓల్డ్ వర్షన్ కదా మీరు ఇప్పుడు?
అంటే నాకు దీని విండోస్‌కి కంపాటబిలిటీ ఆపరేటింగ్ సిస్టమ్ అవ్వలేదు. మరి ఎందుకో తెలీదు. ఆర్ ద ఇంటర్నెట్ స్పీడ్ అట్ దట్ టైమ్ వాస్ నాట్ సో గుడ్ టు డౌన్‌లోడ్. ఐ డోంట్ హావ్ ద సీడీ అన్నమాట.
ఓకే.
ఓకే. సో ఎనీవే దిస్ ఈస్ ఆల్సో యాక్చువల్లీ వర్కింగ్ యాస్ దిస్ ఓన్లీ. యాహ్! ఓకే. ఆల్‌రైట్. వాట్ ఈస్ ద నేమ్? షో డ్రా ఫంక్షన్. చూపిస్తుంది. నాకే కనిపించట్లేదు అనుకుంటా. Okay. Let's this The student is, okay, let me highlight, that would be the best option. Student is actually dependent on the zip also only, if you see. Okay. Student is zip.
Yeah.
Okay. And I'm going with the student is also dependent on what other table? And it's like a course table. Okay. So student is also dependent on course table.
Yeah.
Similarly, if I'm taking this, right, course is also dependent on zip table, right?
Zip table. Yeah.
Yeah, here is also it is dependent on zip table. So what would happen typically? Basic sales.
Yeah, it's okay.
In second normal form, right? We don't establish any of the subsets, the transitive dependencies. Student is on chip and course is also on chip, and student is related to course. Meaning, what is this third normal form, this transitive dependency? In the second normal form, we are not maintaining this, right? We are maintaining zip city address 1, address 2. Course is also zip city address 1, address 2, and blah, blah, blah. So only it is any proper subset of Y is not dependent, something that it was mentioning. Okay. In third normal form, what it will do, if you take theory, A to B holds good, B to C transits relationship should not be present in a table. So in any table, if there is a transitive relationship, meaning, a student is dependent on zip and even course is also dependent on, course table is also dependent on zip. We need to, in third normal form, if they are following the third normal form technique, right? They will isolate these fields and they will maintain it as a separate table. So that you don't have to maintain all these values, right? So now student is dependent on zip, course is also dependent on zip.
So this is called 3NF, right?
Or even here course, you have a core, I mean in student table it is only the zip and the address is there, zip address 1, address 2, state city tables are there, say an example. Okay. And here it is only zip code is there. So it is zip code is also dependent on this, right? So what I can do, I can just write it as a separate statement so that they know the transitive dependency fields, meaning this is course, if I get course, right? Course to A is dependent, again A to C is dependent, A to B is dependent, B to C is also dependent. Then obviously A to C is also dependent. This zip is same as this. So these type of fields should not be there. So you can maintain them in a separate table. Any transitive dependent fields are there, then they will be maintaining it in the third table. So saying that zip and city, all this, the student ID, student name, city, zip is there, and here the course one, student ID, student name, zip is there. Then they are going to remove these two fields and club it into the separate table. Okay.
Okay.
Sorry, it is not student ID, it is course ID.
Okay. Yeah.
Okay.
Course name.
Course name and then zip is there, then they will be segregating. These transitive dependency fields, they are removing and they are maintaining it in a separate table. That is third normal form. Okay. Clear, Andy? Now, what is, let me save this and I'll send it to you, this normalization. What are the merits and demerits of normalization? Let's do that. What do you think? What is the merit of normalization?
It maintains all the data in the
Yeah, so it maintains all the data in tabular format. First and foremost thing is avoids data redundancy. So when you are going with, data redundancy, right? Data redundancy will be avoided. That is the basic, what we call merit of normalization. Okay. So what are the demerits basically?
But still there is like repetitive data.
Exactly. Demerits is there is a, I mean, it is not there is a repetitive data. There could be repetitive data, but the demerit is a lot of complexity, understanding. When
Yeah,
one is designing it right, the relationship should be established properly. What is this
yeah, yeah.
table, what is this table and all. So it is a bit difficult for a normal user to understand it. If I don't have the architecture diagram, which field is actually related to this field and all. So in real time, the fields are not this much straightforward, right? What are all the common keys and all? In order to study that, you need to have a proper architecture or data flow diagram that exists, right? To understand the big
Okay.
picture and all, what are all the common things and all. So it is
Mhm,
difficult for a layman to understand, right? I cannot read
mhm,
it directly if I'm saying. And you will have to write a bit of complex queries also, okay, using the joins and all. Okay. So,
okay.
okay, initially when we went with, first normalization, the drawbacks or limitations are redundant data and huge data storage. Okay. That is why we
Okay.
split this table into second normal form, right? Second normal form, what is the prerequisite of second normal form? Second normal form, it should be in 1NF, and then it should be, table should have a common key or a candidate key. Okay. It can be split into two or more entities and it will be combined through a common key. That is your second normal form. Third normal form, for every normal form that you are going up, it should be in the previous and then it has this extra feature, right? In third normal form, it should be in second normal form, and to eliminate the transitive dependent fields, as I told. Okay, transitive dependency A to B, B to C, then A to C. So you will have to split out the transitive dependency field and we will maintain a separate table. Okay.
Yeah. Okay.
So now the merit, we know the first normal form, the drawbacks is redundant data is there, data storage is there and all. What are the other demerits of a normal form?
As you said, like complexity is one of
Complexity.
it,
Yes, complexity.
is the main thing. Yeah.
420, right? I have this required. Okay. Merits and demerits. Let me write somewhere. So, what are the advantages? More normalized,
Yeah.
less storage space,
Let's do this.
less redundant. Less redundant data. I'm not saying that it is completely redundant, avoided, but less redundant data,
Let's do the
right?
answer.
More normalized. But what is the
Yeah, yeah.
demerit by doing more normalization? Complex.
Complexity.
Yeah, okay. Only difficult to understand the user. I mean, difficult for the layman to understand the tech. Business user, you need to explain him or someone, who doesn't have the complete functionality and all, but you need to have little technical background also on this. Okay.
Okay.
And need to write complex queries to fetch the data.
Mhm.
Okay. So the designing should be appropriate, meaning like, we do have indexing also. There is a concept of indexing. So what would happen when you are writing the queries and all? Less redundant data, and also the first phase is more response time. Okay. You have a huge amount of data. You wanted to take one thing in from the first normal form. Then obviously you do not have a common key, right? Then how do you filter it basically? So you need to
Oh,
identify basically the commonness, the common key, that itself will take time, and then you have to combine all those things and all. Okay. So the response time would be more. Suppose if I'm giving only a student name as, Neha has 100 records enrolled for, various reasons for 100 courses. She discontinued one course, again entered, everything will be there. Then 100 records will be fetched for Neha.
mm,
right?
Yeah.
If I wanted to only know that, Neha, this where she is residing in the city and all, so I can just go with the table A, student number combined with the course ID or zip, and then I'll just, join this with the and zip table, and I'll get the details, right? Where, A dot or something like that.
Okay.
So the response time will be
So,
much more faster. Okay.
yeah, more response time. You mean faster response time?
Faster.
Okay.
So like more
Less
responsive in that
response.
sense,
Yeah.
like what latency in response, latency we call. Okay.
Latency means
It's more
faster and easy.
delay in
Yeah.
response time. Okay.
Oh, delay.
If it is in the
Okay.
more
So
sorry, it is not more it is more normalized, right? Merits, yeah. Faster response time.
yeah, faster. Okay, yeah.
Faster response time. Okay. It is the merit,
Mhm.
right? So more normalized, it is a faster response. However, there is a condition over here
Okay.
that we will be discussing in the demerit. Okay. So this is the complex queries and need to identify the columns appropriately. So you cannot identify candidate key as a text field, which is so difficult to join and all even internally to the system, right? So only the numeric values, so you need to convert them into new, you will have to maintain another column which contains some numeric value and you need to do this join and all. So architecture should be strong enough. Your data modeler or architecture should be strong enough to analyze this data and to come out with the proper design, right?
Okay. Okay.
Okay.
Yeah.
Need to identify the proper columns. Okay. This will be more response if faster response time only if indexing and all is properly done. We'll come back what is indexing also.
Okay. Okay. Okay.
Indexing in the sense like, something like in your, when database is reading, right, we have two properties known as scan and seek. Scan and seek. Meaning, scan means it will go through each page by page, it reads and then it retrieves the value. Each field by field it goes, which takes longer time. But if you are doing kind of index, there's again clustered index, non-clustered index also, meaning you have a primary key defined on this. Okay, we are not going in details on that, but just, non-clustered index in the sense there is no primary key that is defined. But here, clustered index, the primary key is defined. So something like when you are referring the textbook, right? There are two ways. You will go through each and every chapter and you will refer. If you are looking for some specific information, right? You will go through each and every chapter and you will refer. Or if you go through the index and then directly go to that particular place and then get that required information, whichever you feel easy. The first one, right? Sorry, the second one, indexing one. Okay.
Index.
So if you're not maintaining appropriate indexes on the table, indexes is one part of the object on the table. So which is the activity that should be done by DBS, typically database administrator. They need to identify the appropriate data and they need to do this index, based on clustered index or non-clustered. Non-clustered again will take time. This is all comes as part of database tuning and all that stuff. DBS will do that. So, but the demerit is if the indexing is not properly done, obviously you will run into more issues. Okay.
Okay. Okay.
So instead of faster response time, you will get more latency time. Okay. So indexing needs to be done properly. And the biggest demerit of normalization, what you could think of. This is off track. What you could think of.
Biggest
Updating any need.
Update. Sorry.
Okay.
Updating any.
Record. Update data updates.
Okay, any table or
Data updates or inserts into the table. I mean, it is going to, so for that, the constraints and all triggers needs to be appropriately imposed. Say something that, you are inserting the course, that is fine. But you wanted to insert a, not data inserts and updates is a merit. The demerit is if you are establishing kind of preferential integrities and all, right? The course ID, a new course ID, you cannot introduce over here, 6 or 7. Okay.
Okay.
You understand it. There are only 5 courses that are identified. But in the student table, when I'm just trying to insert that 6 value, there is no meaning of this normalization, right? So I have given
Yeah.
6, where it doesn't have any presence of this in the master table of course 6, right?
Okay.
So there will be a data anomaly, inconsistency of data. Okay. During the data updates, or inserts, there might be chances of data anomalies. If constraints have not been imposed properly. We'll discuss what is constraints also. Okay. What do we mean by constraints? So this referential integrity. If I'm saying this is a master table, then I will have to impose a referential integrity, saying that only that it should allow, this particular column should allow the values that exist in this range, in this column. Okay. That we will call it as a referential integrity also. That we will be discussing primary key and referential integrity. Okay. So when you are going with the normalization, you wanted to enjoy the fruits of normalization, then all these things should be properly updated. And sometimes inserts will take longer time also, because if you want to insert this particular table, then it has to first add over here in the master table, and then you can just add this course ID value, right? So redundant data storage, to see what is this normalization. These are the different, and yeah, if indexing is not done properly and all, if it is a huge volume of data, right? If there is any huge volume of data, then ideally people will not recommend normalization.
Normalization, yeah.
Yeah.
Okay.
If the volume of data is rapidly growing, and if it is huge volume, difficult to maintain. They do maintain normalization, but difficult to maintain third normal form, blah, blah, blah. Okay. So if I have to update in one place, then I need to go through all the tables and the proper values needs to be inserted. Because in real time, there will not be hardly 2 to 3 tables, right? A lot of master tables will be there and all. Difficult to maintain, 3 enough. So max to max like 2 enough. Even in data warehouse system, we do maintain only the denormalized data as 1 enough only.
Okay.
Because we don't need, because we are not touching the master tables directly in data warehouse. We will hide all this complexity and we'll create the views, right? So once for all, when views are there, when you are actually retrieving the data every time, you are not going with the master tables. It is only the views that it is touching, the reports and all, when you are refreshing the data and all. Only for transactional databases, right? Transactional databases system will use normalization. Right? The transactional database systems will use normalization. So if it is like, OLAP systems, right, analytical ones, because the data gets refreshed every day, not in every single minute and all, it will not be using any, what we call analytical database systems. Will not use normalization. I mean, it might use, but it is only like denormalization. Okay. These are some of the demerits of normalization and denormalization. All right. Then any doubts in this, Sunday? You wanted to start off SQL today. Unfortunately, could not. You have few more hours, or shall we continue for what are the data definition languages and all that stuff?
లేదండి యాక్చువల్లీ అంత టైం లేదు నాకు.
అవునా?
I'm going out now. Yeah.
Then tomorrow we'll continue with the SQL part, and we will be.
Tomorrow. రేపు సండే కదా క్లాస్?
రేపు సండే. రేపు వద్దనుకున్నాం కదా క్లాస్. మీకు కుదరదా రేపు?
అంటే రేపు ఇంతవరకు మీరు చెప్పినవన్నీ మళ్ళీ రివిజన్ లాగా చేసుకుందామని అనుకుంటున్నాను నేను.
ఓకే, యూఆర్ నాట్ ఫైండింగ్ టైం. ఓకే అండి, దెన్ మండే we will start with the databases అండి. That is this one was completely done. Then we will discuss each and everything, and we will be doing the hands-on anamata. Okay.
Yeah,
The
okay.
schemas, tables, rows, columns, and all. Maybe I can cover in another 10 minutes this part only. Okay.
Okay.
What are the schemas, tables, rows, and columns? That is kind of theory only. So normalization we covered, right?
Yeah.
Okay, this is little off track again.
1NF అంటే ఒక టేబుల్ ఉంటుంది. 2NF అంటే 2 డిఫరెంట్ టేబుల్స్ ని
Two or
కంబైన్
more.
అంటే
2 or more using a common key.
3NF అంటే
ఇంకా
like
ఎక్కువ
3 or
tables
more.
ఉంటాయి.
Sorry?
ఇంకా ఎక్కువ టేబుల్స్ ఉంటాయి. లైక్ డిపెండెంట్
ఇంకా
ఫీల్డ్స్
ఎక్కువ
ఏవైతే
టేబుల్స్
ఉన్నాయి,
ఉంటాయి.
అంటే 2 టేబుల్స్ లో 2 టేబుల్స్ కామన్ కీతో జాయిన్ అవుతారు కదా. ఆ కామన్ కీ కాకుండా వేరే ఏమైనా ఫీల్డ్స్ ఉన్నాయనుకోండి, ట్రాన్సిటివ్ డిపెండెంట్ ఫీల్డ్స్. ఆ ట్రాన్సిటివ్ డిపెండెంట్ ఫీల్డ్స్ అన్నిటిని తీసి ఇంకో టేబుల్ కింద పెడతారనమాట.
Yeah. Okay. So there could be like multiple tables.
మల్టిపుల్
in
టేబుల్స్.
three. And 5NF అంటే మీరు అన్నట్టు
వీటన్నిటికి
ఇంకా
రిలేషన్షిప్స్ ఎస్టాబ్లిష్ చేయాలి. 5NF ఈస్ మోర్ కాంప్లికేటెడ్. ఇన్ఫాక్ట్ ఐ ఫర్గాట్ ఆల్సో బీయింగ్ ఆనెస్ట్. సో దెర్ విల్ బి మాస్టర్ టేబుల్, అక్కడి నుంచి మాస్టర్ టు చైల్డ్. మోస్ట్లీ ఇది కూడా ఎక్కువ యూజ్ చేస్తారు, మాస్టర్ బేస్ టేబుల్, మాస్టర్ టు బేస్ టేబుల్ రిలేషన్షిప్స్ అని చెప్పేసి డేటా వేర్ హౌస్ లో. బట్ 5NF ఐ థింక్ 5NF ఈస్ సంథింగ్ లైక్ కాంబినేషన్ ఆఫ్ 2+3. దర్ ఇస్ సంథింగ్ లైక్ కాంబినేషన్ ఆఫ్ 2 and 3. ఓకే, అంటే ఇవి ఉండొచ్చు, అవి ఉండొచ్చు అని.
బట్ మీరు లైక్ అంటే మీరు పర్టికులర్ లైక్ వర్క్ లో చేస్తుంటారు కదా, లైక్ మోస్ట్లీ 2NF చేస్తారు.
సెకండ్ NF అండి, max to max is 2NF. అండ్ ఈవెన్ సమ్ టైమ్స్ ఇట్ ఇస్ 3NF ఈజ్ ఆల్సో దేర్. సో వాళ్ళ ఆర్కిటెక్చర్ వాళ్ళు చెప్పని కూడా చెప్పరు ఏ నార్మలైజేషన్ ఫామ్ అవుతున్నారు అన్నది, ఫాలో అవుతున్నారు అన్నది. బట్ మనం థియరీకి అర్థం చేసుకోవాలి. దిస్ ఈస్ ఓన్లీ ఫర్ థియరీ అండర్స్టాండింగ్ అండ్ లైక్ ఇఫ్ సమ్మన్ ఆస్క్ ద ఇట్స్ ఇంటర్వ్యూ క్వశ్చన్ యూ షుడ్ బి ఏబుల్ టు ఆన్సర్. కాబట్టి సో అంత రాదు మీకు అసలు, బీయింగ్ ఏ టెస్టర్ అండ్ ఆల్, యూ నీడ్ టు హ్యావ్. మా వాళ్ళకి 10 ఏళ్ళ నుంచి చేస్తున్న వాళ్ళకి ఎవరికి నాలెడ్జ్ ఉండదు. సో లెట్స్ గో బ్యాక్ టు వాట్ ఈస్ స్కీమాస్, టేబుల్స్, రోస్ అండ్ కాలమ్స్ అండి. దెన్ we will directly tomorrow we are going to select only this. Then data types ko cheppadiki we will start creating the statements, even create tables also. We'll start creating the statements and all that stuff. Okay. So this is mostly like theory part was done. ఇక్కడ నుంచి మనం రేపు డేటాబేస్, మీ దగ్గర ఏదైనా డేటాబేస్ ఉందా అండి ఇన్స్టాల్డ్, అది SQL Server ఆర్కి? I do have both. but
maybe I need to check. స్వప్న అప్పుడు నేర్చుకున్నప్పుడు
బట్ నేనేం చేస్తానంటే ఈ మీకు SQL పార్ట్ అంతా కూడా మీకు SQL Server మీద చెప్తాను. వెన్ ఇట్ కమ్స్ టు మీకు మళ్ళీ డేటాబేస్ మనకి కావాల్సి వస్తుంది ఇప్పుడు డేటా వేర్ హౌస్కి వచ్చేప్పుడు. సో దట్ టైమ్ వి విల్ టచ్ బేస్ ఆన్ ఆర్కిల్ ఆల్సో. సో మీకు 2 కవర్ అవుతాయి. కొన్ని కమాండ్స్ మాత్రం ఆర్కిల్లోనే SQLలోనే డిఫరెంట్ ఉంటాయి. అంటే దే ఆర్ సేమ్ ఓన్లీ, బట్ సింటాక్స్ వైజ్ ద వే దే యాక్ట్ ద ఫంక్షనాలిటీస్ ఇస్ డిఫరెంట్ అనమాట. ఎస్పెషల్లీ ద డేటా కంట్రోల్ లాంగ్వేజ్ కమాండ్స్, క్రాంట్ అవి. ఓకే, ఇవి రెండిట్లో చెప్తాను నేను మీకు, ఆర్కిల్లో చెప్తాను, SQLలో. బట్ ఇవన్నీ మోస్ట్లీ లైక్ ఐ విల్ బి కవరింగ్ ఇట్ ఇన్ ద SQL Server అండి. ఐ డూ హ్యావ్ SSMS SSMS వర్షన్ ఉంది, మీకు దాంట్లో కవర్ అవుతుంది. ఓకే. సో లెట్స్ we have 5 more minutes కాబట్టి let's touch base on the objects, like what are the schemas, tables, rows, columns. You know what is a row and what is a column, right? Row is nothing but a tuple, like record where it represents the attributes of all the
Attributes, yeah.
attributes of the properties and all. Okay.
Oh.
So that is a record or a row. And column wise information, we are maintaining the attributes of the particular the attributes of the entity, meaning the properties of the entity, like student number, student name, whatever it is. If it is an employee number, employee name, basic details, basic HRA, all that stuff. Okay. That is known as an attribute. Row is a specific person, employee number. You are storing the data of a specific person entirely, one particular record level you will be maintaining. Table, entity or table, it's a collection of rows and columns. A table is nothing but we are maintaining pertaining to one subject area. Meaning, if it is an employee, okay, employee table, employee basic or employee salary details table. There is an employee salary details table or department table, or you will be having a department table is the number of departments it consists of and all the details, right? You want to maintain employee basic details also, employee table also you can have. Employee salaries you want to maintain in a separate table, you can maintain like that, pertaining to one particular subject area. Whatever is the subject area, one particular subject area, we'll be maintaining it as a table ending. Combination of rows and columns. Okay. What is a schema then? This is known as a metadata. This table, where do these reside? Okay. Under a schema. A database will be divided into environment to schema to tables. All the related tables, collection of tables will be maintained in a schema, particular schema. Suppose you have an insurance only, right? In insurance, there is a one particular schema in one environment, like, like life, all the life tables. So under life, there are n number of customers. Life insurance is there. And another is, kind of health insurance is there. Another is annuities are there. Okay. Or auto insurance is there. For all the vehicles, you are collecting the tables into one particular schema, right? Auto insurance customers are different. Auto insurance customers are different. Under auto insurance itself, I have lots of tables. One is, product, and then claims will be there. Product table is there. What are all the different products that are available? Claims, how many claims have been made, and all claims is there. These are the main things, right, that we are discussing. What next? Mainly the products, insurance, customer information will be there. For all the customers, the claims made, what are all the different products, the plans will be there, what are the different plans and all. These are the main basic tables, right? So schema is nothing but pertaining to one particular major subject area. Like, insurance is the whole lot of subject area. If I'm working in insurance industry, again, there will be auto people who are working on it. Auto end users are different. Life end users are different, life insurance. And because as an entity, take an example of any insurance company, like anything like a country or State Farm or anything like any Northern American insurance companies, then you do have auto, you do have life, you do have annuities, you do have what more? I think like health. Okay, all these four are major sectors. The revenue generation, data warehouse, even transactional systems, we will maintain the schema. Schema is nothing but a superset of tables and where exactly the tables will be created. So initially, what do? They will create a schema, and then on top of it, they will create the tables. And in metadata, where this metadata is going to stored exactly under the schemas. Different objects. Table is just one of the objects under the schema. In databases. Okay, you have other objects also known as, we are not going to dig into that, but views is one more object, one more database object, right? Views are one more database objects. I'll tell you, like, if I'm just showing this, that. So here it is. The databases, this is known as a schema, master model, different databases. See, these are all the different objects of a database. Tables will be there, synonyms will be there.